Okay, 5.5, solving radical equations. Something to be aware of when you break radicals. So I'm going to use the letter A to represent A is any number. The rule is if it's an index value of an even, you're raising it both sides to a power of 2. If it's even root, if it's a cube root, you're raising both sides to a power of 3. And then what happens is the inside comes out. So then we get x equal to a squared and x equal to a cubed. That's some rules that we need to pay in mind. So in the first example, it says square root of x equal to 8. It's an even root. Remember, radical x, when it's radical, means it's implied as a value of 2 in the corner. The index value is a 2, so we're raising the left and the right side of power of 2. When we do that, the x just comes out by itself, and the square of 8 is 64. Now, when it's an even index, you must check. So you take your original equation and plug in your solution. So square root of 64, does that result in 8? Square root of 64 is a positive 8, which equal to positive 8. It worked. So x equal to 64 is our answer. Next example. Same situation. They just added a binomial piece on the inside. So they're saying square root of t plus 19 equal to 1. Again, it's an even index of a 2. So I'm raising the left and right to a power of 2. And we get positive t plus 19, still the same, equaling positive 1. Subtract 19 over. So t is equal to negative 18. Again, because it is an even index, we are checking. You take your original equation and substitute back in. So negative 18 plus 19, does that result in a positive 1? Well, do the arithmetic on the inside. So negative 18 plus 19, that is $1. Square root of 1 is a 1 equaling a 1. It worked, so t equal to negative 18 is our solution. Next example. It says cube root of x equal to negative 1. So now it's a cube root function. So we have our original. You're raising it to an index value. So the index value is a 3. So I'm putting parentheses around the negative 1 to raise it to a power of 3 as well. We do this in case it happened to be an even number and then it changed the sign value. So the cubes cancel each other out, giving you x. Negative 1 times itself 3 times in a row gives you still a negative 1. We do not need to check. You do not need to check, but we will just so that you can see that it will always work. So cube root of x, does that result in negative 1? Well, our x value is a negative 1. Remember, negative 1 times itself 3 times is negative 1, which equaled negative 1, so it worked. Next example. So on this problem, it says square root of x plus 6 equal to 2, and the 6 is not inside the radical. So when you come to problems like this, first thing you need to do is you need to isolate the radical. And then step 2 would be then to solve. So on this problem, I take my original. I need to subtract the 6 over to the right side. So I have radical x equaling now, I had $2 but spent 6, I'm short 4. Even index, so I'm raising both sides to a power of 2, and that's why I put parentheses around the negative 4. I get positive x. Negative 4 in a parentheses squared makes it positive 16. Remember, it's an even index, so we need to check it. So we take our original and substitute in. So 16, square root of 16 plus 6, does that equal 2? Square root of 16 is a 4, and I'm adding 6 additional dollars to it. Well, positive 10 does not equal 2. So because of this situation, this is a DNE, does not exist. This is known as an extraneous solution. So let's look at the hindsight. When we got to, before we squared everything, we noticed that we had a radical x equaling a negative number. So a note to make aware of, if you get radical x equaling a negative number, this is after isolating, then this is D&E. It will not exist. That's another trick. So once you do your mathematics and you get the radical equaling a negative number, you can stop, choose does not exist, and move on to the next example. Next example says radical t minus 13 minus 2 equals 7. So again, we need to take the original. We need to isolate the radical, so I need to add 2 over. So I had $7 and gained 2 more, I have a 9. So now, after we isolated, the radical is equaling a positive number, so we're good. You're gonna square both sides to a power of 2. So we get t minus 13 equaling 81. Add the 13 over. So t is equivalent to 94. But remember, because it's an even index, we need to check it. So we're going to take our original equation. Okay, t we ended up getting as a 94, so I'm subtracting 13 in the radical. 94 minus 13 gives us 81 in the radical. Remember, a square root of 81 is a 9. Minus 2. Does that give us 7? Well, 9 minus 2 is a 7. It equals 7. It worked. So t equaling 94 is our solution. Next example. So in this one it says square root of 10 minus x on the inside of a radical plus x equal to negative 2. So we take our original. We need to first isolate our radical, so I need to move the this x over. Yes, I know it looks ugly because it's got negative values. Just bear with me. So I get negative x minus 2. So now, when we get to here, we need to square both sides. So when you put parentheses around the left side of the radical, when you go to the right side, the negative x and negative 2 is known as a binomial piece, so it's parentheses around the entire piece before you raise it to a power of 2. When we do this, this is perfect squares. Or you can use the box method, depending on how you want to expand it. So when you do the expansion rule here, we just get 10 minus x escaping on the left side. Here we become positive x squared, positive 4x, positive 4. If you don't see it, you can do the box. Put a multiplication dot in the left corner. Write negative x, negative 2. Again, negative x, negative 2. It's repeated. When we do our math here, negative and negative makes it positive x squared. Negative and negative, positive 2x. Negative and negative, positive 2x again. Negative and negative, positive 4. X squared, we have x squared. 2x plus an additional 2x is 4x. Positive 4, positive 4. So either do the expansion rule, or you can use the box to give us to that answer. Since everything is out of the radicals here, we need to move everything to the right side since the higher exponent is on the right side of the equal sign. So I'm going to subtract 10 and add x. So we get 0 is equivalent to x squared plus 5x minus 6 because I had $4 but spent 10. So when we get to this one, we need to factor this trinomial piece. So we need numbers that multiply to negative 6 that add to 5. Well, the only numbers that can do that is 6 and 1. In order to get a positive 5 but a negative 6 in multiplication, 6 had to be positive and the 1 had to be negative. So we are x minus x plus 6, x minus 1. Solve of them, x is equivalent to negative 6, x is equal to positive 1. So we have two situations here, two possibilities. you need to check since the original had an even index. So we're going to take the original problem, 10 minus x plus an x equaling -2. And we're going to substitute in. So 10 minus, and I'm putting -6 in parentheses first, plus a -6 in parentheses, does it result in -2. The reason I did the negatives inside is in case of sign changes, which we see right here in this radical piece. 10 minus a minus means 10 plus, so I get 10 plus 6. Plus minus makes it -6. Notice that the -6 is not in the radical. Make sure you don't make that mistake. So we get square root of 16 minus 6. Does that result in -2? Square root of 16 is a 4. 4 minus 6 now. -2 equals -2. It works. So we know that -6 is one of our solutions. Now we need to verify if the 1 is a solution. So we're now going to plug in a 1 into our original equation. So here's the thing. When I look here, before I even finish the problem, it's the square root of 9 and I'm adding an additional $1. Because the 9 is going to get larger by adding $1, the square root of 9 is going to get larger, I'm never going to get to a negative value, so we do not exist. We do not keep the 1. Next example. So in this one, it's a cube root. It says the cube root of 5x minus 5 plus a 2 equaling 5. So again, you take your original, isolate by subtracting the 2 over to get cube root of 5x minus 5 equaling 5 minus 2, which is a 3. Remember, it's an odd index in this one, so we're raising it to a power of 3 because that's what the index value is. So you get 5x minus 5 equaling 3 cubed, which means 3 times 3 times 3, which is 27. Add 5 over. So you get 5x equals 32, and then divide both sides by 5. So x is equivalent to 32 over 5. It's an odd index, so you don't have to check it. It will work. On the next example, there's radicals on both sides of the equal sign. So since they've already isolated themselves, a radical for each side and nothing else, you can go immediately to the problem. So you take your original. And since in this instance the index values are even, so they're 2's, I'm raising both of them to a power of 2 to both sides. So you get 8x minus 5 equaling 7x plus 5. The bigger x value is on the left, so I'm going to subtract the 7x to the left side. So you get x minus 5 equaling 5. Add the 5 to the right. Remember, it's opposite of the sign. You're getting larger, which is positive 10. Again, remember, it's an even index, so substitute in a 10 for x to see if the left and right equal. So I get square root of 80 minus 5. Does that equal the square root of 70 plus 5? Well, I get the square root of 75 equaling the square root of 75. It works. 10 is our answer. This is just a verification thing. If you wanted to simplify this one step further, remember this is quarters. 3 quarters make 75 cents. So this reduces to 5 square roots of 3 equaling 5 square roots of 3. Next example. Okay, so on this problem it says x plus 3 equaling the square root of 12x. So you take your original problem. So the radical's already isolated. We need to go straight to squaring both sides. Remember, this is a binomial, so the entire thing is being raised to a power of 2, which means here we have again perfect squares or the box method, whichever one makes it easiest for you to expand. This becomes x squared plus 6x plus 9, and on the right side, it escapes. Since the higher exponent is on the left, I'm going to move the 12x to the left side. So I'm subtracting 12x over. So you get x squared minus 6x plus 9 equaling 0. Now, this is a perfect square trinomial right here. The only difference between our finishing product and the one we have up here is the sign in the middle. It's plus here, minus here. So the same thing we did to expand, we break it down. Square root of 9 is a 3. In order to get a negative 6 in the middle, they need to both be negative, because if I add the two negative 6 3's, I get negative 6. If I multiply the two negative 3's, I get positive 9. Since they are the same, there's only one solution in this instance. X is equal to 3. But since it's an even index, we need to check it. So x plus 3, does that result in the square root of 12x? We're substituting in. 3 plus 3 is 6. 12 times 3 is 36 in the radical. So 6 equals 6 because the square root of 36 is 6. It worked. Now, in this instance, because it was two bubbles repeated, the same binomial, this is known as a double root. There's two solutions, but only one actual physical answer. Next example. It's one of your literal equations. So the police department uses a formula for speed, and it says that V is equal to the square root of 20 times L. So it's the length of a skid mark. So they're trying to figure out a crash scene, how fast a vehicle was moving, and then they would use this formula. So in this thing, it says to estimate the speed of a car, velocity in miles per hour, based on the length L and feet of its skid marks when suddenly braking on dry asphalt road. At the scene of an accident, a police officer measures his car's skid marks to be 249 feet long. So they gave us the length. It says approximately how fast was the car traveling? Round your answer to the nearest tenth. 1 decimal answer for the unit. So we're taking our original problem, which is they gave you the formula. It's not changing. It says V equals square root of 20 times L. They tell you L is equal to 249. We're substituting 249 in for L. So now we become V equals 20 times 249. So you take the calculator, you're going to do 20 times 249. We get 4,980. You're going to take the square root of that. So I'm going to do second square, second answer. So I can plug my answer in there. And when I do that, I'm getting 70.56. I went 2 decimal places. But the answer says it wants it 1 decimal place. So I need to verify if the number after the tenths place is greater than 5. So in this instance, it's a 6. So the velocity of the vehicle was 70.6 miles per hour. Next example. So on this one, it says we have 2 radicals, 1 on each side, but then there's a plus 4 here. So this is actually a double calculation, what should I call? So the first thing we're going to do, we're going to take our original. Now, we have to square both sides. So when you square both sides, we're squaring this, and then this, you're treating this entire right side as a binomial, so the entire thing is squared. So again, you have to use perfect squares or the box method to expand. So we become 41 minus 2x equaling. This is going to escape out and you get 9 minus 2x plus sign. These two together doubled makes it 8 radical 9 minus 2x. And then you square the 4 and you get 16. So you can do the perfect square trinomial expansion, or remember you can stick it into the box and it's going to give you the same answer. Now we're at this point. So I'm going to move anything that is not radical related to the left side. So first, before we do that, I need to combine like terms there. So 41 minus 2x slides down. 9 and 16 makes it 25 minus 2x plus 8 radical 9 minus 2x. Now we're going to subtract 25 and add 2x to the right side. So we're going to subtract 25, add 2x. So we get 16, negative 2x and positive 2x cancel, equaling 8 radical 9 minus 2x. Now before we square both sides, notice that the 8 is attached to this radical. So since this is attached by the property of multiplication, I'm going to divide both sides by 8 to get 2 equals radical 9 minus 2x. Now, isolated radical, plain number. Now we can finish the problem. We're going to square both sides. So we become 4 equals 9 minus 2x. Subtract 9 to the left. So you get negative 5 equals negative 2x. Divide both sides by negative 2. So x is equivalent to positive 5 halves. Now we need to verify if that works in our original. So we have 41 minus 2 times, I'm going to write 5 over 2. Does that equal 9 minus 2 times 5 over 2 plus 4? Now, in here, in the radical, positive 2, and remember the 2 and the 2, they're numerator denominator, they cancel out, and you just get minus a 5 here. On this side, again, the 2's cancel, giving you a 5. Do the math. So we get square root of 36. Does that result in 9 minus 5 is a 4 plus a 4? Well, square root of 36 is a 6. Square root of 4 is a 2, and I'm adding 4, so 6 equals 6. It worked. 5 halves is your answer. Next example. Another word problem, literal equation, what we call. So it says v is equal to the square root of 2.3 r. This is a model of maximum safe speed, v, in miles per hour, at which a car can travel on a curved road with a radius of a curvature, r, in feet. So remember how on the highways, when they tell you the speed limit is 35 miles an hour on an exit ramp, this is how they go about figuring this out. So it says a highway crew measures the radius of the curvature at an exit ramp on a highway at 470 feet. It says, what is the maximum safe speed? So first thing, we are taking our original equation. It says v equals radical 2.3 r. They tell you that the radius is 470. So they're telling you that r is equal to 470, and that's what we're going to plug in. So square root 2.3 times 470. So taking your calculator, 2.3 times 470 is 1,081. So v is equal to the square root of 1,081. And this one, you're going to round your answer now down. Remember, you're not going to round up because this is a distance situation. So we're going to round down to our answer. Second radical second answer. So v is equal to 32.87. So we are dropping the 87. So the velocity is 32 miles per hour. That is the safest speed we can take that curve at.